Here's a little bit of a longer problem. We need to write an equation for a scenario and we need to graph it. You are working at Dunkin' Donuts. You get paid $13 per hour and $5 for showing up to work. You get some sort of show up bonus that you get once, and then you get an hourly rate. Write an equation for D, the number of dollars you get paid depending on H, the number of hours you work. So we're going to say D, total number of dollars, is equal to, well, that $5 that you get just because you came to work, plus your rate of 13 that gets multiplied by however many hours you work, right? You work 1 hour, then we multiply 13 by 1. You work 2 hours, we put in 2 for the number of hours, we multiply that by 13. You work 4 hours, we multiply 13 by 4. Okay, so that's why 13 gets connected to the variable which represents the number of hours. Okay, let's move on to part B. Part B says create the graph for the equation on the below graph. And if you notice, there is going to be a part C, so we're going to have to extend this even further. So let's make sure we understand what we're doing. Okay, we have D equals 5 plus 13H. So this axis is our hours, and this axis is our dollars. Okay, and we know we're going to have to use that initial value of 5. So at 0 hours, when you haven't yet worked, you already got $5. And then we're going to have to add 13 for every hour. So I think I would like to count by twos. Let's try counting by twos on the dollars axis, and let's see how that goes. Right? Because you see that gets us our initial value of 5, and then we're going to have to keep adding 13. Okay, so I'm just using a scale factor of 2 to number the y-axis, which represents the amount of money. Okay, keep in mind that as long as you get 2 points, you have a line. So right now I think I can fit, well, I got to add a little more, and then I could fit 3 points, so that's plenty to represent this situation. On the hours axis, I'm just going to count by ones. 1 hour, 2 hours, 3 hours, because I know I can't fit so many hours, because each hour is another $13, so I don't need to count by twos on the hours axis. Okay, so now how am I going to plot these points? Well, I see the initial value is 5 because the constant in my equation is 5, so that means after working 0 hours, you have $5. So that's going to go right there. And then I see a rate of change of $13 for 1 hour. So I want to add 13 for every hour. So if I'm at 5, I add 13. I can look at my y-axis, and I see I counted by twos. 13 plus 5 takes me to $18. Okay, and that's for 1 hour. So I want to put a point right there. Okay, so just be careful. Don't just count 13 boxes, but each one represents 2. So we actually did 6.5 boxes to get $13, right? Or we thought about the fact that it's $5 plus 13, so that brings us to 18. Okay, so we went up 13 for the 1 hour. Okay, if we wanted to show another hour, we'd have to go up 13 again. Okay, so this is 2, 4, 6, 8, 10, 12, 13, up 13 more dollars if she works for 1 more hour. Okay, and that's as much as I can fit here. It's very important that I connect this because I want to show that this is going to keep going. There are more possibilities, right? You can work for 3 hours, for 4 hours, for 5 hours. I happen to not be able to fit that point on the graph, but there are so many more possibilities. So I want to show that with the arrow. Okay, so now we have a complete graph. Let's see part C. What is the initial value? Well, we already said the initial value, our starting amount was $5. Initial value, same thing as the y-intercept, right? How much we start with when x is 0. That's always on our y-axis, and that was 5. 0 hours, $5. Part D, what is the rate of change in this scenario? Well, how much was it changing? It was changing by $13 an hour. So 13 was the rate of change for this scenario.